Hello, I am honored to present this new intervention to you today on a politics of bodies in latent space, contribution to a digital history of the body in art. In 2013, Mikolov, Chen, Corrado, and Dean transformed our understanding of the relationship between language and computation. By training a model, Word2Vec, on a large text corpus, they showed that words, when projected into a continuous vector space, occupy positions whose geometric relationships correspond to semantic relationships. The most famous example is contained in an equation, the vector obtained by subtracting man from king and then adding woman yields a result whose nearest neighbor is queen, Mikolov et al., 2013, Section 4, Table 2. In other words, the vector difference between king and man isolates a direction in space, a direction that encodes something like royalty, and this direction applied to woman leads to queen. The semantic relationship can be described as an algebraic operation on coordinates. This discovery demonstrates that statistical models, without having been explicitly programmed to do so, seem to understand abstract relational structures. But what the equation king minus man plus woman equals queen also reveals is that the vector direction separating man from woman does not capture an essence of gender. The correlation is not ontological. It captures the statistical distribution of co-occurrences of these terms in the training corpus. And this distribution carries within it all the biases of this corpus. Bolukbasi et al. 2016 show that the same vector arithmetic that produces king minus man plus woman equals queen also produces computer programmer, man plus woman equals homemaker, or even doctor, man plus woman equals nurse. These are not errors in the model, they are regularities in the corpus, faithfully encoded. The gender direction in the vector space is not neutral, it carries with it the professional asymmetries, stereotypes, and hierarchies that permeate the text on which the model was trained. The vector inflections are the result of inductions produced from the dataset. Embedding does not represent gender. It constructs it as a geometric axis, and this construction is then silently inherited by all downstream models. No ontological reality, only probabilistic associations. Our approach will delve deeper into this question of bias along two different lines. First, through intermodal benchmarks. When a vision language model like CLIP OpenAI or SIGLIP encodes an image, the resulting vector carries within it the visual and textual regularities of the training corpus, which bodies were photographed, captioned, and associated with which words. A black body captioned athlete and a white body captioned portrait do not appear in the same place in the latent space, not because the bodies themselves differ, but because their captions differ, and these captions carry the history of categorizations. What definitional differences might emerge between the different models? In what sense should a reflection on the politics of latent spaces analyze intermodal tensions? Models do not simply encode the gender or race biases of their data. They encode their historical stratum, their politics of the visible. The same model trained in 2019 and 2023 will not interpret a Delacroix in the same way, not because the architecture has changed, but because the corpus has changed, and with it, the sensibilities, categories, and legends that structure the latent space. It is this temporal sedimentation, this co-presence of historical strata within the weight of a network that we seek to isolate, measure, and make visible. This will lead us to consider artistic tactics, in the sense of Michel de Certeau, that could allow us to intervene in these unconscious political constitutions. When we feed an image into a CLIP model, what happens is not perception, it's encoding. The model doesn't see a body, it projects the image into a 512 or 768 dimensional vector space, where the position of the resulting vector depends on three things: the dataset on which the model was trained, the network architecture, and the historical moment of the training. The body in this space is not an image, it's a point, a coordinate, a location in an abstract topology, and this location is never neutral. As Antonio Somaini reminded us in his lecture on the politics of latent spaces imply a politics through the categories they associate, the semantic vectors they structure, and the choice of data sets that feed them. But how do we make this politics visible? How do we demonstrate it other than through theoretical statements? This question motivated the development of our latent space benchmarking tool. It comprises two distinct exploration modules, an intermodal module and a module for exploring tick-clip checkpoints from 2016 to 2022. The first module allows comparison of distinct models, sglip, OpenAI clip, Latant/OpenClip, and two outdated versions of tick-clip. Let's take, for example, Eugène Delacroix's portrait of a woman with a blue turban, 1828. We defined bipolar semantic axes, colonial/decolonial, masculine/feminine, sacred/profane, Western/non-Western, and calculated a score for each artwork based on these embeddings. By considering the colonial/decolonial tension, we observe that the different models do not constitute this pictorial body in the same way. Sglip tends to represent it as reflecting colonial logic, while OpenAI Clip perceives it as not reflecting this political issue. By exploring the 1,000 paintings provided for this benchmark, we gradually become aware of the structure of each model and its classification principles. The second module involves subjecting the same artwork to several temporal versions of the same model, checkpoints trained on corpora from different periods, and measuring how the interpretation changes. Let's take Eugène Delacroix's portrait of a woman with a blue turban, 1828. Depending on the checkpoint used, this same image shifts along the colonial/decolonial axis. Models trained on recent corpora, where post-colonial sensibilities are more prevalent in image captions, classify it differently from earlier models. The image itself hasn't changed. The painted body is the same. What has changed is the temporal stratum of the model, what we call a chronic persistence, this co-presence of temporalities sedimented within the network's weights. To formalize this instability, we constructed a temporal sedimentation score, SST, that combines the Jensen-Shannon divergence between checkpoint score distributions and median variance. This score identifies which semantic axes are most unstable over time, in other words, which categorizations of the body are most sensitive to the model's date. In our analyses, the sacred/profane axis exhibits the strongest persistence, followed by the colonial/decolonial axis. The masculine/feminine axis, on the other hand, is remarkably stable, suggesting that gender binaries are deeply encoded in the very structure of Clippy, regardless of the period. The computational body and the perceived body do not coincide. As Asperti, Deci, Tonetti, and Wu rightly ask, does Clip perceive bodies as we do? The answer is no. Can we transform or intervene in this? That is what we will now examine. If latent space is politically situated, can we intervene in its structure? In a sense, models present themselves as optimized strategies for configuring the sensible power mechanisms. And we can try to find tactics that, from within these spaces, transgress, displace, and question what has been stratified. Jake Elwes has been addressing this possibility since 2019. His seminal work, ZZ, Querying the Dataset, consists of injecting 1,000 images of drag kings, drag queens, and drag monsters into the FFHQ, Flickr Faces HQ dataset, which contains approximately 100,000 portraits. The injection is quantitatively modest, 1% of the corpus, but its effects on the network's weights are measurable. After retraining, the model can now generate faces it could not produce before. Fluid, non-binary corporealities that did not exist in the initial latent space. Elwes, presenting these results, emphasizes that in unsupervised learning, the model does not posit binary categories, male/female, black/white. It produces a continuous space, a spectrum. As he explains, The latent space is intrinsically queer because it does not operate through discrete classifications, but through neighborhoods in a 512-dimensional space. However, and this is the limitation, this spectrum is constrained by the dataset. If no image of a black trans person was seen during training, this embodiment literally falls outside the latent space. The model does not reject it, it does not censor it, it simply cannot generate it. The absence in the dataset is an ontological absence. The extension of this work, the ZZ Show 2020, then V&A in 2023 to 2024, takes this logic further. A conditional model associates body skeletons with images. The body of a drag performer in motion generates a deepfake in real time, which then re-embodies it through the model. Here, the deepfake is not an instrument of predation, it is a tool of celebration, controlled by the community involved. But Elwes also points to a recent degradation. Models created after 2023, trained with safety filters and RLHF, compress the latent space into a normative cluster. Marginalized corporealities are once again excluded, not by the dataset this time, but by content policy. The latent space, Elwes writes, becomes a cage that must be decolonized. XXX Machina by Erin Robinson and Anthony Frisbee, winner of the 2025 Ars Electronica Award of Distinction, operates a reverse process. Elwes injects to expand, Robinson recursively feeds to collapse. The setup is as follows. A broadcast model is trained on a dataset of prompts scraped from AI-generated pornography platforms. The resulting images are fed back into the model as input data. A loop is formed, the model generates bodies, then retrains itself on its own productions, then generates again. Robinson's critical gesture consists of grafting his own face onto these bodies. What initially appears as conventional pornography cracks with each iteration. Anatomies deform, bodies glitch, fragment, and recombine into configurations that no referent supports. The Ars Electronica jury highlighted the essential point. While debates on AI pornography revolve around faces and their non-consensual use, Robinson draws attention to the bodies themselves, to their status as statistical constructs. The pornographic body in latent space is no one's body. It is the weighted average of millions of images extracted without consent. By grafting his face onto it, Robinson makes this dispossession visible and the nature of the autonomous desiring machine that produces it. The theoretical dimension is embraced. Robinson intersects with Lacan, desire structured by lack, and Baudrillard, the simulacrum that precedes the real. In the recursive loop of XXX Machina, desire is no longer absence. It is algorithmic saturation. The model no longer responds to a real body. It recursively generates the body it has learned to desire to produce. The LoRa, low-rank adaptation technique, is the instrument of this grafting. These small weight matrices injected into the cross-attention layers of the model allow for specialized generation without retraining the entire system, producing a body image that existed neither in the original dataset nor in the real world. This body image is precisely what Carouges would have recognized as the product of a fully realized bachelor machine. In Duchamp's work, the bride of the large glass remains suspended in a perpetual unveiling that never ends. Desire circulates within the apparatus without ever reaching its object. In Robinson's work, the loop closes. The machine produces the body it desires to produce, and this body in turn becomes the object of a desire without a subject. The bachelor machine is no longer lacking its object, it secretes it. Deleuze and Guattari describe the bachelor machine as a recording surface that appropriates all productive forces and acts as a quasi-cause. LoRa performs this operation in the literal sense. A few low-ranking matrices suffice to inflect the entire generative network, producing the illusion of autonomous causality. The machine seems to generate of itself what it has never been shown. But what happens when you produce the model yourself? This is the question my own creative work has been exploring for several years now. revolving around the impossible archaeology of the image. It's no longer a matter of grafting a LoRa onto a pre-trained model, but of constructing the model itself from heterogeneous corpora, in the case of this series, approximately 10,000 images, combining human bodies, knotted boat ropes, and mineral assemblages. The prompt is reduced to its simplest expression, a body in a white room. No predication of deformity, no intention of producing distortion. It's about allowing the image's potential to emerge according to what I call artificial imagination. What then emerges is an archaeological impossibility. For the viewer and for the creator himself in the early generations, the origin of the form is indecipherable. The generated body bears within it the statistical traces of ropes, minerals, and anatomies, but these traces have become irreducibly latent. Faced with the image, one cannot perform the classic archaeological gesture, tracing it back from the visible surface to the layers of sedimentation that produced it. Recognition is suspended. The image cannot be decomposed into its sources. It is neither body, nor rope, nor stone, but the vectorial compression of these three regimes of form in a space where their ontological differences have been abolished, just as in the latent space of Clip, the temporal differences between Van Eyck and Gursky are vectorially abolished. The emerging body is not imperfect. It is perfect according to the AI's perception and learning. It is a pararealism of bodily form, not a distortion of reality, but another reality coherent within its own space of possibilities. Each generation arrives as a surprise because statistical induction operates in dimensions inaccessible to human perceptual intuition. What the AI has perceived in the 10,000 images, the topological regularities between a knotted rope and a joint, between a quartz vein and a tendon, corresponds to no category of our phenomenological experience. The latent body, suspended potentially within the model, is the result of a transduction in the Simondonian sense, an operation that traverses heterogeneous domains and produces a new individuation, irreducible to the initial terms. Elwes injects to emancipate. Robinson feeds recursively to distort and reveal. In archaeology, we explore latent possibilities not ontologically derived from our experience of human consciousness. Three distinct operations, but which converge on the same observation. The body in latent space is distributed, dispersed in statistical correlations between millions of vectors. It is dated. Its coordinates depend on the historical moment of its formation, and it is politically situated. Its presence or absence reflects choices of dataset, architecture, and filtering that are never neutral. The question Manovich posed in 2009, what happens if we use these developments to track global cultures in a new way, takes an unexpected turn here. The issue is no longer simply tracking culture through computational tools. It is understanding that the tools themselves, clip models, diffusion models, LoRa, carry within them a politics of the body. They do not perceive bodies. They encode, distribute, generate, or exclude them according to regularities that are the product of a history, the history of their data sets, their architectures, their filters. The real question, then, is not whether Clip perceives art as we do. It is which bodies the latent space can and cannot generate, and what this capacity and incapacity reveal about the politics of the visible in the computational age. We understand that the emergence of bodies, visible image, depends on another body, which is the algorithmic one, which responds, as we have analyzed elsewhere, to an algorithmic sensitivity, but also to a computational unconscious. Thank you for your attention.